All right, ladies and gentlemen, so the first question asks, list all the elements that will bond with themselves to become more stable. List all of our diatomic elements, elements that bond with themselves to become more stable. Who could tell me one of them?
Oxygen.
Oxygen, perfect, that's one. Who could tell me another one?
Hydrogen.
Hydrogen, awesome. What's another one?
Chlorine.
Chlorine, perfect. What's another one? We've said hydrogen, oxygen, chlorine. There are going to be four more. Who could tell me another one?
Iodine.
Iodine, perfect.
Fluorine.
Fluorine, awesome. Two left. Bromine, awesome. What's the last one?
Nitrogen.
Nitrogen, perfect. So we have hydrogen all the way in that top left corner. And it's going to be nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So our 7 diatomics, they bond with themselves to become more stable so that they're not sitting there by themselves. Number 2 says, how does balancing equations relate to that law of conservation of mass? So first, who can remind me what the law of conservation of mass tells us? Who remembers what that law of conservation of mass is? Who remembers what the word conservation means? Anybody know that one? Or conserved?
When something stays the same.
Awesome. So when something stays the same, so the law of conservation of mass, somebody said, was that mass is neither created or destroyed in a chemical reaction or in an equation. So why does balancing equations help us with that law of conservation of mass? What do we do when we balance those equations? When we balance equations, what are we really doing? We're making sure we have the same number of what on each side?
Elements.
Of elements, perfect. We want to make sure we have the same number of elements on each side. And so they relate because when we balance equations, we're making sure that the law of conservation of mass is true. We're making sure we keep the same number of atoms on both sides to follow that law of conservation of mass. Any questions on that? All right. So then I do want to go over that formative you guys took last week. So last week you guys took this first formative on types of reactions. So going through this one, so question number 1, we have aluminum chloride and bromine reacting to make aluminum bromide and chlorine. Just solely on types of elements, compounds, or mixtures, we have a compound right here and an element right here. I know this is a compound because I have 2 capital letters versus 1 capital letter tells me it's an element. On my product side, I've made a new compound in a different element. So this one, if we have a compound and an element, the bromine, the element, came in and replaced chlorine, kicking chlorine out, making this a single replacement reaction. Bromine took the place of chlorine. The element replaced part of that compound to create the new element and new compound.
Oh,
Any questions on the first one?
that's
All right.
crazy.
If you do have questions, send it in the chat or say it out loud. And then I'm going to keep going with number 2. So we have this C2H6 compound plus oxygen, O2,
Oops, that's making
making
Margaret
CO
died. I
and
will
H2O.
into the
Anytime we see a CH compound reacting with oxygen, or anytime we see the CO2 and H2O both being produced, we know this has to be a combustion reaction. We have our fuel source right here reacting with oxygen to make carbon dioxide and water. Number 3, right here, we have calcium chloride and aluminum nitrate making calcium nitrate and aluminum chloride. When we have this reaction, we have 2 compounds right here. They're reacting and 2 new compounds were produced. When we have 2 things being replaced, so calcium's replacing aluminum and aluminum is replacing calcium. We have a double replacement reaction. 2 compounds, the metals switch spots to create 2 new compounds. Oh, that was supposed to be erased, but now you already know these 2. All right, but this one is synthesis, and that is because we have 2 things combining to make our one product. Whenever we have one product, it's a synthesis reaction. And if we have one reactant breaking down into multiple products, we have a decomposition reaction. Any questions on those 5? All right. Then down below, you guys are writing out those equations into formulas. So you need to find out what those formulas were. Beryllium sulfate should be BeSO4. And lithium nitrate is LiNO3. And they're making beryllium nitrate. This one is going to be BeNO3 2. Because beryllium has a +2 charge and nitrate has a -1 charge. Yes, we do have to worry about those charges. And then the last one should be lithium is Li2SO4 because we have a +1 and a -2 charge this time. In the next question, we have carbon tetrahydride. So it's going to be CH4. And oxygen's a diatomic, so it's O2. Making carbon dioxide, which is CO2. And dihydrogen monoxide, which is just water, or H2O. The next one, we have aluminum and oxygen, so it's just Al for aluminum, plus oxygen, which is O2. Making aluminum oxide. And so we got to look at our charges. So we have a +3 and a -2, which gives us Al2O3. And then last but not least, nitrogen trichlorides, which is NCl3, makes nitrogen and chlorine, which is N2 and Cl2, because they are both diatomics. Questions on those four? Then the last question down here says, in a lab setting, how would you be able to determine if a combination of reactants produces a chemical reaction? What do we look at to figure out if we produce a chemical reaction? Who remembers? Color change, perfect, that's one.
Temperature.
Temperature change, awesome,
Odor.
that's two. What'd you say?
Odor,
Odor, perfect.
bubbles, or bubbling,
Gas or bubbles produced. All right, what else? There were two more.
precipitate,
Precipitate, perfect. Which is a solid form.
and light being produced.
Perfect. Light or energy produced. Awesome. Any questions on anything from this formative? All right. So then today's assignment is this word problem practice. So you guys have 5 problems here. What you're going to be doing is pulling out those formulas and just writing out the equation, and then you're going to balance the equation. So kind of like that formative where you're pulling out all that information. Now this time you also need to balance the equation when you're done. So do you guys want to do one together?
Yes,
All right, so let's look at that first one. It says potassium chloride reacts with magnesium sulfite to form potassium sulfite and magnesium chloride. So the first thing we want to do again is find out where our yield sign is, that arrow. So what word or words tell us where the arrow is going to be?
To form.
To form, perfect. This right here tells us that we're making something new. So that's where our arrow is going to go. So now let's figure out which ones are reactants and which ones are our products. So who can tell me a reactant or a product?
the potassium sulfite is a product,
Awesome. Potassium sulfite is a product. So I'm going to put a P above it.
and the magnesium chloride is a product.
Awesome. We have 2 products. Do we have any reactants?
Yes,
What are they?
potassium chloride and then magnesium sulfite.
Awesome. So we have 2 reactants and 2 products here. So before we go do anything else, what do we think this is? A single replacement, double replacement, combustion, decomposition, or synthesis? We had to take a guess. Double replacement is perfect. We have 2 different compounds reacting to make 2 new compounds. We have 2 things switching spots, so we're going to have a double replacement reaction here. All right, so now we actually have to write out this equation. So we have potassium chloride is our first reactant. So we need to figure out how to write this in formula form. So we need to figure out what potassium is as an ion and what chloride is as an ion. And then we have to find out what our formula is going to be. So what is potassium's element symbol?
Okay,
Okay. And what would the charge be when it became an ion?
K minus 1, or no, I mean K plus 1.
K plus 1, perfect. And then what's chloride element symbol?
Cl.
Cl, awesome. And what's chloride's charge?
-1.
-1, awesome. So we were gonna make a formula for that one, what would it be?
Wouldn't it be KCl?
It would just be KCl, perfect. All right, the next one we have is magnesium sulfite. All right, what is the element symbol for magnesium?
+2. Mg +2.
Mg with a +2 charge, awesome. What's sulfite?
SO3 -2.
SO3 -2. So if I were to make a formula out of that one, what would it be?
MgSO3.
MgSO3 is perfect. So we have plus MgSO3. And then it makes our first product, which was potassium sulfite. I'm going to steal them from over here on the left side. So we have K with +1 and SO3 with a -2. So what's my formula going to be for that one?
KSO3. I mean, no. K2.
K2SO3. Perfect. Because we need 2 potassiums for the charges to add up to 0. And then last but not least, we have magnesium chloride. I'll steal those from over there. Perfect.
MgCl2.
MgCl2, perfect. This time we need 2 chlorines to balance out the charge of our magnesium. All right. Now we need to balance our equation. All right, so we're going to balance our equation. We're going to draw our line going down. We have, and I usually also draw another line right here just to separate everything. So we're going to have our potassium, chlorine, magnesium, and our sulfite on both sides. And I'm going to keep them on the same spots, even though they switched. Who could tell me how many potassiums I have on my reactant side?
Just 1.
Just 1. What about chlorines?
1.
How many magnesiums?
1.
And how many sulfites?
Just 1.
Just 1. Perfect. This is 1 set of sulfite. All right, on my product side, how many potassium?
2.
How many chlorine?
2.
How many magnesium?
1.
How many
Oh, yeah.
sulfite?
That's social studies. Okay, I'm listening in while trying to get the dragon scale for my horsey.
I'm just gonna type in here. That's
Okay. I don't
How
know
many
what that
sulfite?
cat wants. I don't know what that cat wants. She walked in my room and then she's like, no.
How many sulfite?
1.
1. Perfect. All right. Are they balanced already?
No.
No. So how do I balance them?
Multiply potassium and chloride by 10.
All right. We're multiplying our potassium by 2, giving us 2, which you said put this 2 where?
In front of KCl.
In front of KCl. So that
And then
gives
you
us
have
2.
to,
All right. We balance now?
yeah.
All right. Nice job. Any questions on this? Any question on what you have to do for the next 4 problems? All right, then you guys have 4 more problems. You do not have to stay to complete those 4 problems, but if you have any questions, just let me know.
I have a question.
What's up?
How do you know the charge of the elements? Is it on
So-
the periodic table?
Yes, so the big part for that one is going to be, where's my periodic table? I probably passed it like 3 different times. There it is. Okay, so we're looking at our periodic table. For most of these, so if they're in these columns, we can figure it out because all of our elements always want to get to this column. They all want to have 8 valence electrons. So our elements, if they have 1 valence electron, will always lose that 1 valence electron because it's easier to go backwards. So if we're at potassium and they lose 1, they end up at argon. So it's easier to go back 1 than try and move over 1, 2, 3, 4, 5, 6, 7. So it's easier to lose that 1 than try and gain 7. But these guys over here, like oxygen, if we're trying to get to 8, we can either gain 2 or we can lose 1, 2, 3, 4, 5, 6. So it's going to be easier to gain 2 than it is to try and lose 6. So if we're gaining electrons, we're going to add, or we're going to add negative charges. So this would have a -1 charge if it gained 1 electron. These guys would have a -2 charge. These guys would have a -3 charge. And then it goes the opposite way. If we're losing electrons, we're losing a negative charge. So these guys would have a +1 charge. These guys have a +2 charge. These guys have a +3 charge. These guys are special in that they do funky things because of where they sit. Because they're at 4, they can do 4 back or they can go 4 forward. So those guys are going to be a little bit trickier to figure out. And that's going to be the same thing with these guys over here, our transition metals. So if we don't see it on our periodic table, because they're not one of those nice columns that we can check, the other place we do have to look is our polyatomic ion sheet. So if we look, we have something like sulfite was right here, which is SO3 with a -2 charge. It tells us what that charge is. And things like lead, that PB that was in column 4, could have 2 different charges. So we have to look at the Roman numerals. And same thing with anything in our transition metal section. Most of them are going to have Roman numerals. Like copper has 2 options, cobalt has 2 options, chromium has multiple options. So either they're going to have multiple options and we have to look at our Roman numerals, or it's on there, but it only has 1 option, like gold only has 1 set of charges, which means it only is going to have that +1 charge. It'll never have a +2 charge for gold.